Orbital Gardens, this is Mission Control. We are confirming acquisition of your signal. You are live in 5, 4, 3, 2...
Hello and welcome to episode 27 of Gardeners of the Galaxy, a podcast that exists because every gardener needs more space. I'm Emma the Space Gardener and I will be your host as we explore gardening on Earth and beyond. It has been an entire solar orbit since I launched Gardeners of the Galaxy, and to celebrate I've got a really exciting show for you. I'm going to tell you about an astrobotany experiment you'll never forget. And after a year of asking other people what their fantasy space plant is, I will reveal my own. That's all coming up later in the show, but I'm going to start by explaining a bit of the Gardeners of the Galaxy backstory, which is how an earthbound organic gardener became interested in space plants. So how does an organic gardener, firmly rooted in the soil, develop an interest in plants grown in space? I've always had an interest in space exploration. I grew up with Jean-Luc Picard, and I have a bachelor's degree in astrophysics, so I have probably spent more time than most thinking about the cosmos. I was a space nerd before becoming a gardener, which didn't happen until I had my own house and garden. I started growing some herbs and vegetables because of my interest in the environment. Food miles was a big thing at the time. But I fell in love with plants, and edible plants became an obsession. I just wanted to learn as much about them as possible, and grow all of the ones that would survive in my garden. That passion drove me to do a master's degree in ethnobotany, which is the study of how different cultures make use of plants. It can be anything from baskets to building materials, but my main focus is on food plants. And shortly after that, NASA launched the first veggie growing system to the International Space Station, and that was what really sparked my interest in plants grown in space. The technical details of how that's done are interesting, and one of the exciting things about space exploration is that it's helping us to solve problems on Earth. Astronauts on the ISS and on future off-world missions won't be able to rely on constantly replenished natural resources. They have to keep their energy use low and recycle as many things as they can. And in developing those systems for spaceflight, we're creating new technologies that can be used here on Earth, such as providing clean water in remote locations and growing more food with fewer inputs and less environmental damage. Surrounded by plants as we are on this planet, it's easy to take them for granted. When we think in terms of plants in space, we can see how vital they are for our survival and well-being. And I believe telling those stories is a great way to cure plant blindness and create new generations of plant fans. But my real fascination is the ethnobotany. Astronauts are essentially creating a new plant culture from scratch, and that's amazing to watch. I love finding out which plants are chosen and why, and how that varies between astronauts from different cultures here on Earth. Which is why I am Emma the Space Gardener, and you're listening to the first anniversary edition of Gardeners of the Galaxy. So, as promised, now it's time for me to tell you an astrobotany story you'll never forget. In June 2021, Procter & Gamble announced that they would be working with NASA to develop laundry systems for space. As part of that programme, NASA will be testing and studying Tide cleaning solutions. You may be wondering what astronauts have been doing with their dirty laundry all these years. The answer is that they wear their clothes for longer than we do here on Earth, and when they're irredeemably funky, they get thrown in the garbage, which generally comes back to Earth in a space capsule trash barge and burns up on re-entry. There are good reasons why astronauts don't do laundry. They don't have the time. The ISS has limited power, and water is in short supply, and wastewater is processed back into drinking water. However, each astronaut NASA launches to the ISS needs around 72 kilos of clothing per year. Looking ahead to Mars missions that will be 2 to 3 years long, that's a lot of clothes to pack. The issue then becomes both the volume of space the clothing takes up and the energy cost, which translates to a financial cost, of launching it all into space. So, anyway, next year, Mission PG Tide, which stands for P&G Telescience Investigation of Detergent Experiments, we'll see ISS experiments testing the stability of cleaning ingredients under microgravity conditions and exposure to the radiation levels experienced in space. The ISS crew will also evaluate the stain removal ingredients and performance of Tide to Go wipes and Tide to Go pens. So far, so fascinating, but what does it have to do with space plants? Over the years, many articles on space laundry have referred back to a 2003 NASA article called Astronaut's Dirty Laundry. It refers to a time when astronaut Don Pettit retasked his dirty underwear into a planter. It says, when science officer Pettit recently decided to try and grow some tomato and basil seeds he had aboard the station, he had a problem. Since there's no soil, he had to figure out some other way to grow the plants. In his Space Chronicles, Pettit wrote, "To construct my planter, a spherical core is needed. An old pair of underwear worked well. We have supplies on station sufficient to change our underwear perhaps once every 3 to 4 days, so I figured there might be a few nutrients in there as well. An old pair of underwear was folded into a sphere and held in place with a few well-placed stitches using needle and thread from our sewing kit." For the outside of the planter, he sewed some Russian space toilet paper to the outer surface of the underwear. He said, "This toilet paper is not like what you normally think of as toilet paper. It consisted of 2 layers of coarsely woven gauze, 4 by 6 inches in dimension, sewn together at the edges with a layer of brown tissue sandwiched in between. It works very well for its intended purpose. It also makes a wonderful sprouter." After Pettit solved a problem that was causing the seeds to stay too cold to germinate, the seeds sprouted in the underwear toilet paper planter within 2 days. So when I read that, I was intrigued. I wanted to know more. Where did the seeds come from? Was anyone brave enough to eat crops grown in Don Pettit's underwear? However, I struggled to find any more details. Eventually, I found Don Pettit's Expedition 6 blog posts archived on the Wayback Machine. So this is his full report of his impromptu astrobotany project. Growing plants in the weightless environment of an orbiting spacecraft is much harder than meets the eye. Having a supply of tomato and basil seeds, I tried my hand at growing them, with results proving that it is not as easy as the first time I tried this for science class in 2nd grade. I do not have the necessary ingredients to grow healthy plants to fruition. We have no dirt on space station. I have no soil or soil substitute and no fertilizer to supply the necessary macro and micronutrients through hydroponics. However, it is possible to investigate sprouting, where the new plant structures live off the nutrients from their seed starch. The best I could expect is to have healthy seedlings for a few days and then have them turn yellow, wither, and die as they starve from the lack of potassium, fixed nitrogen compounds, and all the other micronutrients. With this in mind, I set out to construct a 0G sprouter. Lacking soil, you need some sort of substrate that will retain both seeds and water. I considered using an old shirt or sock, but decided the Russian-supplied toilet paper was best. This toilet paper is not like what you normally think of as toilet paper. It consisted of 2 layers of coarsely woven gauze, 4 by 6 inches in dimension, sewn together at the edges with a layer of brown tissue sandwiched in between. It works very well for its intended purpose. It also makes a wonderful sprouter. It retains water well, and the seeds can be anchored under the gauze weft. My first thoughts were to arrange the seeds in little rows on the rectilinear squares of toilet paper. Only then did it occur to me that being on space station could offer new possibilities. Why not a spherical planter? Every direction is the same as the rest, and a sphere would offer some interesting possibilities. The limited lighting, both from window and artificial sources, can be shared by the spherical surface if the sphere is attached to a string and allowed to freely rotate in the air currents. It will then be constantly moving and bobbing around like a helium balloon on a string, and thus share the lighting with all its surfaces. The plants can enjoy the 1/r² potential given by spherical geometry. A spherical geometry gives increasing surface area as the plants radially expand, surface area needed for leaves and photosynthesis. They will not have to partake in foliage fights like plants do when grown on a rectilinear flat plane, where surface area for foliage becomes limited as the plants grow upwards. It also allows one small spherical volume in which to circulate hydroponics via capillary action. A spherical geometry for growing plants in limited volume makes good sense if you have weightlessness. To construct my planter, a spherical core is needed. An old pair of underwear worked well. We have supplies on station sufficient to change our underwear perhaps once every 3 to 4 days, so I figured there might be a few nutrients in there as well. An old pair of underwear was folded into a sphere and held in place with a few well-placed stitches using needle and thread from our sewing kit. The toilet paper was sewn to the outer surface. A drinking straw was sewn so that its opening was in contact with the fabric and could thus be connected to a drink bag to provide a continuous water drip via capillary action. Seeds were planted with a pair of tweezers by carefully working each seed between the weft of the gauze. The sphere was initially watered and then attached to the water bag by a long thin plastic tube, which also functioned as a string and hung by a light in the node. It bobbed around in the air currents. I became concerned when, after a few days, no sign of sprouting had occurred. The water bag was working well in keeping the sphere moist and was consuming about 100 millilitres a day. I touched the sphere. It was cold. The cabin air temperature was warm at 28 degrees centigrade. I measured the sphere at 18 degrees. Evaporative cooling was acting like a refrigerator and slowing germination. A plastic enclosure was constructed out of plastic bags that made the plantosphere into a miniature greenhouse. A few holes were poked through the side for ventilation, just like you did in the jar lid when you were in second grade. The plastic enclosure slowed the rate of evaporation and resulted in temperatures around 30 degrees centigrade. Within 2 days there were sprouts. However, not all was well on the plantosphere. Gravity plays an important role in sending roots down and stems up. Without gravity, every direction is the same. Roots and stems were exiting the seed and growing in any direction within the plane of the spherical surface. The lighting provided an outward growing cue. However, its effects were small compared to the effects of capillary forces. Capillary forces, subtle in nature and derived from the water interface on the damp layers of gauze, convinced the sprouts to ignore the outward direction of the light and to grow in the surface plane of the sphere. Each sprout had deployed its cotyledons, 2 miniature leaves that jumpstart photosynthesis and provide for the growth of its real leaves. Cotyledons are the drogue chute equivalent before the main canopy is deployed in a parachute system. The capillary forces were overpowering the effect of the outward direction of light. Without gravity's direction, it was as if the sprouts were lazy and decided to give in to the subtle capillary forces instead of standing upright to light's beckoning. The cotyledons, constantly covered with a warm layer of water, rapidly moulded and withered. Without a drogue chute, the main canopy will not deploy, and you will have a hard landing. Without cotyledons, the sprouts died. It is imperative to make the sprouting leaves grow through the water film as quickly as possible, thus surrounding them with fresh air. It was too late to save this batch of sprouts, so a new batch was started. This time, as each sprout deployed its cotyledons, they were carefully pulled by hand out from the grips of surface tension and allowed to freely spread their leaves in the surrounding air. This batch of sprouts did as well as you could expect, having only their starchy seed pod as a source of nutrients. After an inch or so of growth with budding main leaves forming, they turned yellow and died. When you live inside of a metal can filled with machines and electronics, a small splash of growing green is a pleasant reminder from where we came. We all have our roots. I could not help but feel a small sadness for these living creatures that were giving me so much delight, while I was powerless to help them grow strong. So, there you go, an astrobotany experiment you'll never forget. You can now wow people at parties by telling them about that time a NASA astronaut sowed seeds in his underwear. Sprouting underpants wasn't the only time Pettit got involved with unofficial plant experiments on the International Space Station. In 2 bonus episodes of Gardeners of the Galaxy, I recap his adventures growing space zucchini and his friends space sunflower and space broccoli. To listen to those and access other bonus content, sign up via Patreon for as little as £3 a month via patreon.com/Gardeners of the Galaxy. Over the course of the last year, I've loved welcoming guests onto Gardeners of the Galaxy to share their space plant stories. We've heard from scientists who have sent plants into space, educators training the next generation of astrobotanists, and analogue astronauts who are working out how we'll live in space in facilities right here on Earth. Every single guest has been a really good sport and answered my fantasy space plants question. If you were joining a community on the Moon or on Mars and you could only take one plant with you, which one would you choose, and why? Choosing just one plant is a nightmare scenario for a gardener. We love them all. Guests have chosen everything from beautiful orchids and zinnias to practical sweet potatoes, and even agave in the hope of making space tequila. So it seemed only fair that I turn the tables on myself and figure out what my answer to the question would be. Now, I assume that I am joining the community as the resident space botanist and will be involved with growing food plants on a daily basis, by which I mean that if there isn't a space greenhouse, I'm not going. So if the fruit and vegetable needs of the community are sorted, all I have to worry about is taking along a personal plant, a plant pal. And if you're going to have one houseplant for the rest of your off-world life, what do you choose? Something unkillable? One that changes on a seasonal basis to give you something to look forward to? or an unchanging vegetative companion that serves as your plant anchor in an unfamiliar world. Some people go for colour, and that's a good idea since the inside of a space settlement is likely to be bland and sterile, lots of white and steel or institutional beige. But a year ago, I had just come home from the hospital after having surgery, and one of the first things I did was to put a dab of perfume on my pillow so I could fall asleep with a pleasant scent. It wasn't that the hospital smelt bad, in fact, I don't remember it smelling of anything at all. And it was that absence that I was trying to dispel to make myself feel at home. On Mars or the Moon, humans will have to live in a sealed, pressurised environment. When they step outside, they will have to wear a sealed, pressurised suit. They won't be able to stop and smell the roses because there won't be any. Inside the habitat, the air will be recycled and processed and will probably smell like antiseptic garbage and BO. So I think I would choose a scented plant to take off world. I have a rose-scented geranium in one of my herb planters, which has a lovely scent when you brush against it. It also has pretty flowers, and it has some edible uses, although I have yet to try them. So I would have colour, scent, and potentially a fun new flavour to play with. Maybe that's what I'd take. Of course, next time I think about it, I might choose something else. If you know which plant you'd take into space, you can let me know. If you can record yourself explaining your choice, I can add that directly into the show. Or you can just write an email and I will read it out. Either way, the address is earth@spacebotany.uk. You can also find me on Twitter and Instagram at Orbital Gardens, and the Gardeners of the Galaxy show has its own Facebook page. And if you're a Discord user, you can come and say hi in the Space Greenhouse chat room. That's it for this special anniversary edition of Gardeners of the Galaxy. The show's official birthday is Tuesday the 27th of July. I've been working on some ideas for birthday cards and birthday cakes, so look out for those on Tuesday. In the meantime, if your thoughts are leaning towards gifts, what I'd really love this year is if you could leave a review for the show on Podchaser or share the link with your friends or on social media so we can grow our Space Gardener community. I hope you'll join me for the next episode of Gardeners of the Galaxy as the show starts its second orbit around the sun. In the meantime, happy space planting. Thanks for listening. Goodbye.
Orbital Gardens is mission control, confirming termination of your signal. I've thought about it, and the plant I would take to Mars would be an oak tree, because I want to breed squirrels on Mars. Mission control out.